This question is about the microscopic meaning of what internal energy is, and the answer to this question is A. So we need to know that internal energy is the sum of the kinetic energy and the potential energy of all the particles in a system. So when we know this, then we zoom into understanding what potential energy is and also understanding what kinetic energy is microscopically. So kinetic energy is a measure of how fast the particles are moving, and it is directly related to temperature. The higher the temperature, the higher the average kinetic energy of all the particles. So that's why statement D is a correct statement. Now, a thermometer measures temperature. So a thermometer measures indirectly the average kinetic energy of the particles. So that's the reason why A is not really true, because a thermometer measures temperature, which is related to the average KE. Is the temperature that doesn't measure the total energy, which is the internal energy of the system. Now, finally, for internal energy, there is a kinetic energy component. There is also a potential energy component. So potential energy, for statement B, when we do work on the object, it means that there is some force present, because work done is energy transferred through the action of a force. So when we try to compress a system, and when we try to compress a system, the particles are forced to become near to one another, and the distance between the particles will change, and therefore the potential energy of the particles will change. After all, in chemistry, you learn about a chemical bond, and it's related to how close or how far apart the particles are. So when the particles are being compressed to be very near to one another, then the potential energy will change, and therefore the internal energy of the object will change. That's the reason why statement B is the correct statement.